civic establishments don't even need spaceships to migrate from star system to star system. In around 5 billion years, the Sun will lead the primary succession and become a red Goliath. It'll extend and change into a glaring, malicious ball and consume and obliterate Mercury, Venus, Earth, and most likely Mars. Might humankind at any point endure the Sun's red Goliath stage? Extraterrestrial civilizations, ETCs, may have proactively confronted this existential danger. Might they at any point have to endure it by moving to one more star framework without the utilization of spaceships? Universe Today perusers are knowledgeable about the hardships of interstellar travel. Our closest adjoining nearby planet group is the Alpha Centauri framework. In the event that mankind needed to escape an existential danger in our solar system, and in the event that we could distinguish a planetary home in Alpha Centauri, it would in any case take us more than 4 years to arrive, in the event that we could go at the speed of light. It actually takes us 5 years to get an orbiter to Jupiter at our innovative stage. There are heaps of discussed age starships, where people could reside for ages while on the way to a far-off livable planet. Those boats don't have to arrive remotely close to the speed of light. All things considered, whole ages of people would live and kick the bucket on an excursion to one more star that requires hundreds or millennia. Pondering yet unadulterated dream as of now is entertaining. Is there another way we, or different developments, could get away from our destined homes? The writer of another examination article in the International Journal of Astrobiology says that ETCs may not require starships to get away from existential dangers and travel to another star framework. They could rather utilize free-drifting planets, otherwise called rebel planets. The article is Moving Extraterrestrial Civic Establishments and Interstellar Colonization, Suggestions for SETI and CETA. The writer is Irina Romanovskaya. Romanovskaya is a professor of physics and astronomy at Houston Community College. I recommend that extraterrestrial human advancements might involve free-drifting planets as interstellar transportation to reach, investigate and colonize planetary frameworks, Romanovskaya composes. Also, with regards to the quest for different human advancements, these endeavors could leave techno-signatures and ancient rarities. I propose conceivable techno-signatures and relics that might be created by extraterrestrial civilizations involving free-drifting planets for interstellar movement and interstellar colonization, as well as methodologies for the quest for their techno-signatures and ancient rarities, she said. It's conceivable that maverick planets, either in the Milky Way or a portion of different many billions of cosmic systems, convey their own existence with them in subsurface seas kept warm by radiogenic rot. Then, at that point, on the off chance that they meet a star and become gravitationally bound, that life has really utilized a maverick planet to move, ideally, to someplace more friendly. So for what reason couldn't a development mirror that? We consider free-drifting planets dull, cold, and ungracious. Also, they are except if they have warm subsurface seas. Be that as it may, they additionally offer a few benefits. Free-drifting planets can give steady surface gravity, a lot of room and assets, Romanovskaya composes. Free-drifting planets with surface and subsurface seas can give water as a consumable asset and for insurance from space radiation. A high-level human advancement could likewise design the planet for a significantly more noteworthy benefit by controlling it and creating energy sources. That's what Romanovskaya proposes in the event that we're nearly utilizing a controlled combination. High-level civilizations could as of now be utilizing it, which could change a freezing maverick planet into something that could uphold life. The creator frames 4 situations where ETCs could exploit maverick planets. The principal situation includes a maverick planet that ends up passing by the homeworld of an ETC. How frequently that could happen is attached to the number of maverick planets overall. Up until this point, we don't have any idea the number there are, however, there are unquestionably some. In 2021, a group of specialists declared the disclosure of somewhere in the range of 70 and 170 maverick planets, each the size of Jupiter, in one locale of the Milky Way. Also, in 2020, one review proposed there could be upwards of 50 billion of them in our system. Where do they generally come from? Most are reasonably launched out from their nearby planet groups because of gravitational occasions, yet some might frame by means of gradual addition as stars do. One more wellspring of rebel planets in our solar system's Oort cloud. On the off chance that different frameworks likewise have a haze of items like this, they can be a plentiful wellspring of maverick planets shot out by heavenly action. Romanovskaya expresses, stars with 1 to 7 times sunlight-based mass going through the post-primary grouping development, as well as a cosmic explosion from a 7 to 20 times sun-powered mass begetter, can discharge Oort cloud objects from their frameworks so that such items become unbound from their host stars. Yet, how frequently can an ETC, or our human progress, anticipate that a rebel planet should come close to the point of catching a ride-on? A recent report showed that the parallel star W0720, Scholz's star, went through our solar system's Oort cloud quite a while back. While that was a star and not a planet, it shows that items cruise moderately nearby. In the event that the examinations that foresee billions of free-drifting planets are right, some of them probably cruise nearby, or directly through, the Oort cloud well before we possessed the ability to recognize them. The Oort cloud is far away, yet an adequately progressed development could have the capacity to see a rebel planet drawing nearer and go out and meet it. The subsequent situation includes utilizing innovation to direct a maverick planet more like a progress home. With adequate innovation, they could pick an article from their own Oort cloud, expecting they have one, and utilize an impetus framework to guide it towards a protected circle close to their planet. With adequate lead time, they could adjust the item to their requirements, for instance, by building underground safe houses and another framework. Perhaps, with sufficient innovation, they could change or make a climate. The third situation is like the subsequent one. It additionally includes an article from the Progress External Solar System. Romanovskaya involves the Bantam planet Sedna in our solar system, for instance. Sedna has a profoundly unusual circle that takes it from 76 AUs from the Sun to 937 Australian dollars in around 11,000 years. With adequate innovation and lead time, an item like Sedna could be transformed into a departure transport. The writer takes note that developments equipped for doing so would be progressed civic establishments that as of now have their planetary frameworks investigated to the distances of no less than 60 Australian dollars from their host stars. There are loads of expected issues. Bringing a Bantam planet from the far-off scopes of the solar system into the inward solar system could disturb the circles of different planets, prompting a wide range of dangers. However, the risks are relieved in the event that human progress around a post-primary succession star has proactively relocated outward with the changing livable zone. Romanovskaya examines the energy required and the timing expected in more detail in her article. The fourth situation additionally includes objects like Sedna. At the point when a star leaves the primary succession and extends, there's a basic distance where items will be shot out from the framework as opposed to remaining gravitationally bound to the withering stare. In the event that an ETC could precisely decide when these articles would be launched out as rebel planets, they could set it up in advance and brave it of the perishing planetary group. That could be phenomenally dangerous, as times of vicious mass misfortune from the star make a colossal risk. In these situations, the rebel planet or other body is definitely not a long-lasting home, it's a raft. For every one of the above situations, free-drifting planets may not act as a super-durable method for getting out from existential dangers, the creator makes sense of.